Hey friends, this is Meher. You all are welcome in my channel. Let's start the topic types of stresses. Let's start. What is stress? Stress हमने पढ़ लिया था. Stress होता है internal force per unit area. Stress is defined as internal resisting force per unit area. Now today lecture is types of stresses. There are basically two types of stresses. First is normal stress. Second is shear stresses. Normal stresses and shear stresses. Stresses are classified in two parts, that is normal stress and shear stresses. Normal stress is further classified in two parts, that is direct normal and bending normal. It is not of overuse. Surface pressure is also there, but it is not of overuse. And shear stresses are also classified in two types, that is direct shear and torsional shear या फिर tensional shear. No, it is torsional shear. And normal stresses are classified as direct normal. Direct normal are of two types, that is tensile and compressive. And there is bending normal, which is also two types, bending tension or bending compression, which we study later. Okay, stresses are of two types, that is normal stress and shear stress. There is also third type of stress, that is combined stresses. Combined stresses. Normal stresses are of two types, direct normal and bending normal. Shear stress is also two types, direct shear and torsional shear. Now we see what is normal stresses. What is normal stresses? Normal में first direct normal. First is direct normal. Direct normal are of two types, that is tensile and second is compressive. If load is acting normal to the cross section, this is our cross section, load is acting normal in 90 degree to cross section, normal to cross section. Due to this load, stresses occur is direct normal. It may be tensile, it may be compressive. If forces are of this nature, then this is tensile forces. If forces are of this nature, then this stresses developed is compressive stresses. In tensile stresses, there is force which try to pull the material. In compressive stresses, there is a force which try to push the material. Means in this compressive stresses, length going to reduce, and in tensile stresses, length going to increases. Now bending normal stresses. Bending normal stresses is induced due to bending of beams. Like this is beam. If we apply a bending moment which is of hogging nature, it may be sagging. What happens after applying bending moment? Beam will deflect like this. In top fiber, length is going to increase, and in bottom fiber, length is going to reduce. In top fiber, length increase, in bottom fiber length decrease, because in bottom fiber there is compressive force, in top fiber there is tensile force. These stresses are induced due to bending of beam. So these stresses are known as bending normal stresses. These are also two types, that is tensile and compressive. If I see cross section of beam, there is a neutral axis, because when stresses changes from compression to tension, negative to positive, there is point where stresses is zero. This point is known as this axis is known as neutral axis, where stresses are zero. That axis is known as neutral axis. This is neutral axis where stresses are zero. In top there are tensile stresses, in bottom there are compressive stresses. These stresses are normal to the cross section, therefore these stresses also known as bending normal stresses. These bending stresses can be calculated by using bending formula, that is sigma equals to m upon I into y. Y is measured from neutral axis. Because at neutral axis y is zero, therefore sigma is zero at neutral axis, because y is zero, and sigma is directly proportional to y. Therefore relation is linear. This is distribution of bending stresses. And we know distribution of normal stresses. If we apply normal force in any beam, okay, distribution, if beam is prismatic, then we assume distribution of these stresses as uniform. But in actual, these stresses are not uniformly distributed. These stresses are distributed in central portion of beam. If beam is prismatic, we assume that stresses are uniformly distributed and beam is prismatic. Now we can see the failure of material when we apply tensile force. Like these cracks are developed in material and material fails whenever we apply tensile force. If we apply compressive force, material is of failure is of like this. And now next is shear stresses. Shear stresses are of two type: direct shear and torsional shear. Direct shear, first of all, shears. What is shear stresses? Whenever forces, whenever we apply forces along the tangential direction, along the tangent of cross section, अगर हम फोर्स को क्रॉस सेक्शन के, लेट अस सपोज दिस इज आवर क्रॉस सेक्शन, वी अप्लाई फोर्स along the tangential direction of cross section, then therefore due to this force the stresses induced are direct shear, like this. If this is cross section, this is cross section here, if we apply forces in opposite direction, there is sliding of material due to tangential force. This force is in tangential direction of this cross section, and this force is also in tangential direction of this cross section. Therefore this stress is induced due to sliding of material or due to tangential forces are known as shear. Now shear stresses, whenever we apply a force along the tangential direction, then due to this force there is change in shape. This material tries to deform like this. Okay, due to this deformation, the stress which induced in this material is known as shear stress. Shear stress is induced due to tangential force or sliding forces in beam. Like this is beam, there is this is simply supported beam, and there is point load. Due to these two loads, material, look at here, this material try to slide, this section try to goes in upward direction and this in downward direction. Due to this sliding, there is shear force along the cross section. This shear force is known as direct shear force. Now we see torsional shear stresses. Whenever we apply a torque in shaft, this is a shaft. Whenever we apply a torque in shaft, let us suppose torque is T, then due to this torque shear stresses are induced in this member, which is equal to 16 T by pi d cube. Maximum shear stresses are equal to 16 T by pi d cube. This shear stresses is calculated by using torsion formula. Whenever we apply torsional force in shaft, then there is shear stress in that. These shear stresses are not uniformly distributed. These are non-uniformly distributed, which we study in separate chapter. Okay, now combined stresses. Let us suppose a beam. If I apply a load of P which is not passing through CG, this is CG of this section. If this is not passing through the CG, then there is some eccentricity. Due to this eccentricity, what happen if I transfer this P force in along the CG of this cross section, then there is also transfer of moment. Due to this P force, there is direct normal stress, plus due to this bending, there is bending stress is also, which is equals to M upon I, PE upon I into Y. These are known as combined stresses. And if I apply torque T in shaft and a bending moment M in shaft, due to this torque there is a shear stress in this member, and due to this moment there is direct stress in this member. So these are also known as combined stresses. Now with the help of this frame, we can see this is tension because forces is along, which is for forces normal, and it is of pulling nature, and it is of pushing nature, therefore it is compression, and it is of sliding nature, therefore it is shear. Okay, now with help of this frame we can see all types of stresses simultaneously in this frame. This is compression, this is tension, this is bending, this is torsion, and this is shear. These are the different types of stresses. Now in this picture, this is tension, this is compression, and this is shear along this cross section. Now this is it, friend. Hope you like my lecture. Thank you.